You know, I was wondering, if you could keep on because the force.
Lesson 510, Linear Programming 2. Now, most of the time in real life, you don't have the system already. You just have a bunch of parameters set out, some information given to you, and you have to build the system from the information given to you. Let's take a look at an example. Two students, Mike and Thad, want to make jewelry for some extra cash. Every week, they have 10,000 grams of metal and 20 hours to work. Okay? It takes 50 grams of metal to make a necklace and 200 grams to make a bracelet. Each necklace takes 30 minutes to make and each bracelet takes 20 minutes. The profit on a necklace is going to be $3.50 and the profit on each bracelet is $2.50. How many of each should they make to maximize their profits? Now, these guys are smart cookies. They are taking and they know that if they can set up a system and do a little linear programming on it, they'll be able to figure out the most efficient combination of bracelets and necklaces to maximize their profits. Alright, now in order to do this, they're going to have to follow 5 steps. First of all, they're going to have to identify their variables, and then they're going to have to identify their constraints, the things that are holding them in. And they're going to have to translate those constraints into a system of inequalities that relate the variables. Then they're going to have to graph the system and find the vertices of the feasible set. Then once they have those vertices, they're going to write a formula or an expression to be maximized or minimized, and that will be their profit in this particular case, their profit expression. And then the vertices from the feasibility, those coordinates into the profit expression, and I'll examine all the vertices and see which one will make them the most money. Alright, doesn't sound too bad as long as we can follow 5 little steps. Alright, step 1 is to identify your variables. Well, there's 2 things here that we're looking at. The number of necklaces that are made each week, I'm going to call that N, and the number of bracelets. Step 2, identify your constraints. See, what do we know about N and B? They can't be negative. Alright, so N has got to be greater than or equal to 0, and B has got to be greater than or equal to 0. Alright, let's see, another constraint. It takes 50 grams of metal to make a necklace. Okay, so for every necklace made, we're going to use 50. So 50 times N would give metal to make a bracelet. So plus 200 times the number of bracelets made. And every week they only have 10,000 grams to work. So this has to be less than or equal to 1,000 they have. We can come under 10,000, but we cannot go over. Alright, what else? Our next constraint has to do with time. It takes 30 minutes to make a necklace, and it takes 20 minutes to make a bracelet. And the guys are going to work for 20 hours, or 60 minutes in an hour, so 60 times 20. We're looking at 1,200 possible minutes they have in a week to work. They could work less, but they can only work a maximum of 1,200. So here we have a system now that describes all of our constraints. Step 3, graph the feasibility on the horizontal axis and the number of bracelets on the vertical. You can see we're in the first quadrant here. This line represents this inequality. We wanted everything below it. This line right here represents this inequality, and we want everything below it. So this shaded portion right here, which would be discrete because we want to know just the number of complete necklaces, but a complete area under many dots to each and every one of them. So we've just marked a few and then we've shaded. There is a visible region or set, and our vertices are at 0, 50. If we make no necklaces, we can make 50 bracelets. And over here, if we make necklaces of the 2, make 8 necklaces and 4 bracelets. And these right here will use up every single bit of our time, all of our minutes, and all of our metal. So these are the vertices of the feasible region. Now it's time for step 4. Write a formula or an expression to be maximized. Now this is going to be our profit, not our cost, our profit. All right, we said earlier that every necklace is going to bring in a profit of $3.50. And every bracelet will bring in of $2.50. If we go ahead, we can plug these points into this and figure out the corresponding profit. But we know from the linear programming theorem that the only ones that are going to give us a maximum in this case are either this one, or this one. So we only have to check the vertices in this equation, the vertices of the feasible region in this equation, and find out which vertex is going to maximize our profits. So let's do that. If we plug in vertex R at 0,50, no necklaces but 50 bracelets, that would be, okay, we would make no necklaces, so it'd be 0 times 350 plus $2.50 times the 50 bracelets. That's going to give us $125. Alright, now let's come and try this one right here. If we make 40 necklaces but no bracelets, it would be $3.50 times 40 plus $2.50 times 0, which is $140. Alright, so this option is actually going to produce more money than that option, but there's still one more to consider. We have to take a look at this vertex. If we make 8 necklaces and 48 bracelets, that'd be $3.50 times 8 necklaces plus $2.50 times 48 bracelets. That's going to give us $148. $148. So this right here is going to be our maximum point. This is going to maximize profits. Of course, assuming they sell them all. Alright, so there we go.
You know, I was wondering, if you could keep on, because the force, it's got a lot of power, and it makes me feel like it makes me feel like